So section 1.5 is about function operations, adding, subtracting, multiplying, and dividing polynomials, and then also looking at the composition of functions. So I think we're in a good shape with adding functions. We just combine the two functions and add like terms. When we subtract, we have to make sure to distribute the negative sign to all terms. That has been an issue for us that we're going to have to come to grips with. Then product, multiplying, so foiling or double distributing, or if we have three things, multiply by three things, doing the box to make sure everything gets multiplied. And then when we are dividing, we need to make sure to note that the denominator can't equal 0 for the domain. So example 1, let's use f of x equals x squared plus 2x and g of x equals 2x plus 1. And then add, subtract, multiply, and divide these. So when we add them, we have x squared plus 2x plus 2x plus 1. We combine our like terms. We have 1x squared. We have 4x. And then we have a constant of a 1. So that is our added function. So over here we have f of x minus g of x. And remember, in subtraction, the order matters. So we have f of x minus g of x. And I'm going to put g of x in parentheses so that way I remember to distribute the negative. So we have x squared plus 2x minus 2x plus 1. Combine like terms, we have x squared. Positive 2x and negative 2x cancel. So we have x squared plus 1 as our subtracted functions. Multiplying these two functions, we have x squared plus 2x. X squared plus 2x times 2x plus 1. And then we distribute. So we have 2x to the third plus x squared plus 4x squared plus 2x. And then we'll combine our like terms. 2x to the third plus 5x squared plus 2x. So far it hasn't been difficult. Let's look at the last one. We're going to divide them. So we're going to do f x squared plus 2x over g of x, which is 2x plus 1. Okay. So now we have to see, can we simplify that? Well, we can't really simplify that. We can't factor anything out of the numerator that will cancel with the denominator. So that's as far as we have to go. We do need to make sure, though, say, all right, we can't have a 0 in the denominator, so 2x plus 1 equals 0. 2x equals negative 1. X is equal to negative 1/2. Now, the directions didn't say interval notation, so we can just say x can't equal negative 1/2. This one, we have some radicals involved, so that's going to make things a little bit more complicated. So we have the square root of x over the square root of 4 minus x squared. So remember when we talked about domains, when we were dealing with rational functions, we did the domain before doing any simplifying. So we want to do that. So in the numerator, the domain, it's just the square root of x. So x has got to be greater than or equal to 0 because of the numerator. Then in the denominator, we'd have 4 minus x squared is greater than or equal to 0. And then through some algebraic manipulation, multiplying both sides by -1. And then when we multiply it by that -1, we get x squared minus 4. We have to flip the sign, though, because we multiply by -1. And then this factors to x minus 2 times x plus 2 is less than or equal to 0. And then we can draw our rough sketch. 2, -2. We have our parabola. Less than means it's going to be underneath. So that the domain for this part would be from -2, 2. So when we combine them, this one up here, x is greater than or equal to 0, would be 0, infinity. So when we combine those two, the domain is going to be 0, 2. Because the denominator says we can go all the way down to -2, but the numerator says we can only go down to 0. The numerator says we can go all the way up to positive infinity, but the denominator says we have to stop at 2. All right, so now that we've settled the domain issue, we can get back to actually simplifying this, because we can't have a radical in the denominator. So we multiply the top and bottom by the denominator. So what that does to the denominator is it makes it go away. Now we have the square root of x times the square root of 4 minus x squared. Because they're both square roots, we can multiply the insides. So we could write this as x, the square root of x times 4 minus x squared, close parentheses, all over 4 minus x squared. And believe it or not, that is as simplified as we are going to take it. And then our domain is from 0 to 2. And notice how I changed this from a bracket to a parenthesis, because it's in the denominator. So it should have been a parenthesis. It should have been this the entire time. Parenthesis, because 2 can't be included. We can't have 2 plugged in. So that'd be our final answer. So the next page, we're going to evaluate the function, and we're actually going to plug in something instead of x. So f minus g of -2 means we're going to plug in -2 for x and then subtract f minus g. So f of -2 equals -2 squared plus 1, which is 5. G of -2 is -2 minus 4, which is -6. And then it says f minus g. So we have f, which was 5, minus g, which was -6, which gives us positive 11. Now so an f times g of -4. Well, let's find f of -4. -4 squared plus 1, which is positive 17. And then g of -4, -4 minus 4, which is -8. So then we're going to multiply them. 17 times -8, and that equals -136. So what we're doing is we're plugging in or substituting in these values and then doing what the function is telling us, subtracting or multiplying. Now letter C is a little bit different because we're plugging in t plus 2 for x. So f of t plus 2 is going to be rewritten as t plus 2 squared plus 1, which we can rewrite as t squared plus 4t plus 4 plus 1, which then we can combine our like terms and get that. So that was f of t plus 2. Now g of t plus 2 is going to be t plus 2 minus 4, which is going to be t minus 2. So now I can add those. We're going to add t squared plus 4t plus 5 plus t minus 2. And then when we combine our like terms, that's going to give us t squared plus 5t plus 3. That'll be our added function. So again, adding, subtracting, multiplying, and dividing isn't too terrible when we're dealing with combining functions. Is we have to make sure we're doing them in the right order and we're paying attention to the domain. Now, composition of functions. So what composition of functions means is that I'm taking one function and plugging it in to another entire function. So when we have composition of function, the order matters. So it can be written as f of g of x like this, or f of g of x like that. And that, like I said, that means you're taking the whole g function and replacing the x's in the f function with the whole g function. And in a picture, it kind of looks like this, where we plug in x into the g function and then take that result and then plug that into the f function to get the f of g of x. So example 4, we have let f of x equals 3x plus 2 and g of x equals 2x. So f of g of x means I'm going to take my g function and plug it in or substitute the x in the f function. So 3x squared, well, instead of writing x, I'm going to write g of x, which is 2x, and then squared plus 2. Well, this becomes 3 times 4x squared plus 2. Oops, 4x squared plus 2. And then that can be simplified to 12x squared plus 2. So that was g of f of x. Sorry, f of g of x. G of f of x means I'm going to take my entire f function and replace the x and the g function with that. So instead of writing 2x, I'm going to write 2 times the entire f function. And then distribute, we get 6x squared plus 4. Notice that it's completely different than what we got in letter A, so the order does matter with what we're doing. Then letter C, f of x means I'm going to take my f equation and plug it into itself. So instead of writing 3x squared plus 2, I'm going to write 3 and replacing x with the f function, which is 3x squared plus 2. And people will forget about this extra plus 2 at the end that was in the original function. Oh, and I forgot squared because it was x squared. So now we have to simplify this so that 3 is going to stay in front. And then 3x squared plus 2 squared, we have to multiply out. And that's going to give us 9x to the 4th plus 3 times 2 is 6, but then times 2 using the shortcut is going to be 12x squared plus 4. And then we still have that plus 2 at the end. We'll distribute that 3. So we get 27x to the 4th plus 36x squared plus 12 plus 2, which then gives us a final answer of 27x to the 4th plus 36x squared plus 14. So compositions can get tricky, especially when we're having exponents involved. So just make sure you are very careful with those. So thanks for watching. Make sure to like and subscribe.